Aside from chemical propulsion, literally everything that happens in space is electrically driven in some way. Your electric thrusters, your transmitters, your sensors, all of that is electrically powered. And every single thing electrically powered has a source of power that it's getting its power from, and it goes through some kind of power processing unit to turn it into the kind of power you need to run the system. So we sort of see ourselves right in the middle of that stack. Being able to handle high power systems becomes the unlock for all these new capabilities on orbit.
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Gary Calnan, CEO and co-founder of CisLunar Industries, a Loveland, Colorado, go Colorado, company that just closed an oversubscribed $2.6 million seed round and flew its epic power processing tech aboard SpaceX's Transporter 16. Gary and his team are turning space debris into an industrial resource. Gary, thanks for joining me today.
Hey, how you doing? Thanks for having me.
Yeah, this will be fun. Love your background because it's pretty non-standard. So talk to me kind of from the beginnings, and then you got into a finance background, and then you jumped into, space. So walk me through that journey.
Yeah, so I've always had a fascination with space. Always wanted to be, somehow involved in it since I was a kid. Wanted to be an astronaut someday, and hopefully I'll still get to fly to space one way or another here. But as it becomes more of a reality, I started my career actually as an entrepreneur. So right out of college, I had a startup company called Night Riders, which is in Boulder, Colorado. We totally unrelated to space, but I started it while I was still in my senior year, and it was kind of like a real-time MBA. And I graduated from CU Boulder with an economics and business degree, so that so the mix of the entrepreneurial and inventiveness piece of it with some of that business that I wanted to put to practice there. When that company ended up not working out after about 4 years, I went into the corporate world, spent my about 12 years doing corporate finance, got my CFA. I was I did some portfolio management for an asset manager here in Denver for a little while. And then before I went into the space industry, I was director of finance at a SaaS software company in south of Denver that was doing workforce management software, B2B kind of stuff. So I got a lot of interesting finance experience from that whole journey. But I the whole time, I was pretty good at doing spreadsheets, and that was one of my skills to do that. But I found myself wanting to get both back into entrepreneurship. And also try to make a move into space somehow. And around that time, say 2015, 16 timeframe, we started seeing, I think that, that was when we started seeing entrepreneurial space become a reality. We had companies like Planet Labs and SpaceX making real progress. I had the sense that this thing might be starting to become an opportunity where, it's not just about being with NASA or a large company, like other companies, small players, entrepreneurs can get involved. And, it felt like to me, and it still kind of feels like we're on this early stage, that this was like the internet in the 90s. At that time I was a teenager, couldn't really get involved in it, but I feel like these big waves that happen in the economy, you only get a few of those in your lifetime. And this just lined up so nicely with my other interests. I'm like, I got to figure out a way to get into this. So I actually, to get into the space industry, I found out about an entity called the International Space University, which most people don't know about, but it's actually been around for over 30 years. It has alumni all over the world. It's this international program, and they run this space studies program that's 9 weeks long. And, you learn about the space industry, everything from rocket propulsion to art and space and business and economics, everything in between. Right. And they bring people from all different kinds of backgrounds from all different countries. It just so happens that a lot of companies that you've heard of have been founded by alumni from this institution. So I went to that in the summer of 2017. I left my job as the CEO or as a director of finance at the SaaS software company I was at. And, I went there with the intention to try to find some people who wanted to try to start a company who had the technical background that I didn't have, and figure out what area needed a new business. And prior to going into that, I had this notion that I sort of had, after my research, I had realized that resources, the ability to utilize resources in space, was kind of one of the fundamental building blocks for creating a sustainable presence beyond Earth for humanity. So I decided that if I'm going to go into this as a total outsider, I might as well try to do something that's right out on the frontier, and do something that would help to support that resource utilization capability. So that was how I got into the space industry, and it's been, the company was founded at ISU. While we were finishing that program up, I found my co-founders, most of my co-founders there. The most recent co-founder joined us through our connection with the Colorado School of Mine and their space resources program. He came, Joe Kowalski, as our CTO in 2020. But the company started off, as you said, as doing resource processing and trying to do in-space manufacturing related stuff. But it has evolved a lot since then. So I'm sure we'll get into all that.
Yes. International Space University. How long is it? I've never heard of it. Fascinating.
Yeah, the ISU, it has a headquarters in France. They have a master's program they run there that's like an accredited space studies program. But they also run these seminars that are 9 weeks long, and those go to different cities every year. So the year that I did it, it was in Cork, Ireland, and I'd never been to Ireland before, so that was also kind of cool. You get some international travel and kind of spend 9 weeks just dropping out of reality and doing only space stuff and trying all bunch of things you're not good at, and just to see what's possible. So.
Oh, that's pretty big move to just pack up and go.
Well, I mean, it's like I packed up. My house was there. My wife and daughter were here in Denver. I sort of abandoned them for 9 weeks. My wife graciously allowed me to go pursue this wild dream, and it was good timing too, because the company I was coming from had just merged with their largest competitor, and there was some opportunities to earn like a stay bonus for helping them integrate and all that kind of stuff that happens when those events occur. And it just worked out well for me to put those two pieces together and be able to, go pursue this crazy dream.
So at this university, you're just, in the bar talking with other people to see who wants to start a company, and here's kind of your idea, and that's how it kicked off.
I mean, sort of, yeah. I was out most of that event was really socializing. It's like a giant networking event, really. So I was meeting all the different participants there. There's about 200 students. And I just found some people who were of like mind, wanted to start something, like the idea of resources in space. And what is interesting about it is, instead of like having a technology that we then tried to find a market for, because I don't have a technical background, I just wanted to impact this part of the economy. We sat down in front of a whiteboard, and really like, okay, what are the resources? What's currently being done? And you've got, people trying to do asteroid mining. It's 2017. So you had like planetary resources, deep space industries. They just all gotten funding. It looked like they were actually making that happen. And they did kind of pull it from the realm of science fiction to something people thought could be real. But those guys who had companies doing in-space manufacturing, like Made in Space and Tether Limited and some others. And then you had companies talking about landing on the moon and setting up, industrial base there. But we just didn't see, as we mapped out that value chain, we saw the miners, we saw the manufacturers. We didn't see anyone who was like the steel mill that takes the mined resources and turns it into input materials that the manufacturers could use. So, we're like, okay, well, somebody in this new industry, this new industrial revolution, has to be like the Andrew Carnegie of this century. Might as well be us. Like, we should build that metal processing capability. And that's kind of how we landed on the initial idea for CisLunar Industries, which was, to build the steel mills of space, to build a metal processing capability, which then evolved into an idea to use space debris as the first resource for that, which would then sort of kill two birds with one stone. And then interestingly, and not surprisingly, it was a little surprising to us, I guess, is we had this ambitious idea that this was going to happen soon. But it turns out that the market for materials in space still doesn't exist. It's going to be there. It's probably going to be there sooner than people think, with all the push for the moon and so on. But, you can't really build a business and raise money on something that's that far out in the future. So we ended up, working on some programs that led us to our current focus, which is around power electronics. And now that's become the big opportunity. I still have visions of the future where we do get, we're still the thought leader on this like idea of recycling debris in space, and we stay engaged in that. But it's still kind of out on the roadmap concept.
Sure. So as you've shifted, now give us then, what is CisLunar doing right now? What is your full thesis? And
So CisLunar Industries, we have evolved this technology. It was originally created for a electrically powered metal furnace in space using electromagnetic induction. We built our own custom power supply for that. And while we did a few research projects with NASA and Space Force pursuing this idea. And while we were working on the Space Force project, we realized that, and in fact, it was one of our research partners at CSU in their plasma propulsion department who noticed that the power electronics we made for the furnace looked like they could be really useful for electric propulsion. And so it seems like a very different thing. But what we found out was that because when you melt metal, you have to make it very, like, you have to have a very flexible system. Applying that to electric propulsion had some really big advantages. And that led us to where we are today. So today we are focused on power electronics. We build specifically power processing units, power transformation systems, power management distribution, all built around a core capability. This designed to, that core architecture is designed to be modular and scalable. And cross-functional, so that it reaches really all the different layers of the space economy. Realizing that, like, aside from chemical propulsion, literally everything that happens in space is electrically driven in some way. Your electric thrusters, your transmitters, your sensors, all of that is electrically powered. And every single thing that is electrically powered has a source of power that it's getting its power from, and it goes through some kind of power processing unit to turn it into the kind of power you need to run the system. So we sort of see ourselves right in the middle of that stack, and this critical component that because it's so flexible and able to be adapted to different use cases, can actually serve across the entire industry for all the power management and transformation needs. And that's what we're focused on right now today. So we built units for electric propulsion, for our foundry, for a high voltage application for e-beam welding in space. We've got a very high voltage sensing application that we built one for. So we're already developing these systems and actually couple testing them and using them. We have a test platform for part of our PPU in orbit right now on a NASA mission. So, these systems are already pretty fully along the development path.
And why is this different than what was done? What was the standard? It doesn't sound like a revolutionary idea. You have to take
It doesn't sound like, right? Yeah. Yeah. So what we've observed is that there was an architecture that was applied before. And just keep in mind, I'm not an engineer, so I can't go into great detail about the different electrical architectures. But the previous approach, was tried and true. It's been used on missions since the beginning of space applications. And some of the features of it is it for a PPU that runs electric propulsion, it needs very specifically conditioned power, coming into it to run the system. It has certain levels of efficiency and so on. There have been some new changes in what's possible in the industry based on the materials that are available now. So, like, GaN-based chips are now commonplace. They have a lot of advantages for power electronics in space from a radiation perspective and an efficiency perspective. But the big unlock for us was that because we were using it for foundry at first, and when you melt metal, you have to have it be automatically adjusting to the changing electrical properties of that melting metal. As it heats up, it changes. And it has to dynamically change to match that, so you can keep the right temperature. That ability to dynamically shift from the architecture we use is the big difference here. And what that allows us to do is add a lot more resiliency, to remove certain components that would previously be conditioning the power and setting it up so that it's just right going into the end system. And it ends up being very flexible and scalable to a wide range of applications. So we hit the scale that, say, a SpaceX gets because they build thousands of satellites, so they make thousands of PPUs. They get that kind of scale. But everyone else, especially when you get the higher power levels, are really building, only a handful of systems. Even if you've got a constellation, maybe it's 100 or 200, but you're not getting to the thousands of scale, right? And so you never really hit that level of practice where your process gets really good and you can make it very consistently. And that's where we're headed towards with our system.
Did you have to give up engineering wise something as you look to then cover all these different, you know, different designs or large and small and, different use cases?
Yeah, that's an interesting question. So sometimes people think of it when we say modular and scalable. When they think modular, they think like each subcomponent is encased in its own, contained system, and then they have interfaces that click together like Lego pieces. It's a little bit like Legos in a sense, but it's not. Each one is its own module. What we're talking about is specific subcomponents, and this might be a anode driver or a controllable piece or whatever. There's a bunch of little subcomponents that go into a power processing unit. Each of those subcomponents can be, you can configure the number of each and which ones you use, but they all go into, one single unit once we've picked out the configuration for a certain application. What we found is we're actually not giving up we're actually, we have really good efficiency. We're not losing that by being able to cover different use cases. What's reusable? It's not one single thing that can use everything. It's certain subcomponents added together in the right combination so you can do a certain application. And some applications are very similar to each other and have mostly the same parts. If we go from one Hall effect thruster to another, it's almost all the same, and you can change it mostly with software. You need to change it. If you go from a Hall effect thruster on power supply to high voltage, well, most of that is different actually, but it uses some of the same architecture and concepts going in. So we've learned lessons on how to develop it, but the way that the components are configured, you might be significantly different. In any case, the end product is designed to optimize for efficiency and mass. So we're trying not to make those trade-offs, even though we can cover a wide range of things.
Yeah. So are you trying to then, you've created this, is there a lot more evolution that needs to happen, or is this now more scaling? You've got the technology capability, is this more scale play? And then when are you pivoting more towards this, collection of debris?
Yeah. I mean, the debris part might be down the road, 5 to 10 years out. We'll see, that. And actually for the metal thing, metal processing, I suspect, and recycling too, that is more likely to happen first on the lunar surface than in orbit, just because I think that's where it's going to be easier, to do it there. And there'll be a need to make sure we're not piling up different dead, rovers and stuff around everywhere. And that's probably coming, in the next 10 years, actually, that need. But for the business where we are today, we have over the last, as we've been developing this product, we started in 2017, got our first contract in 2021 with NASA. And since then, it's been kind of this upward trajectory. As you noted, we just finished our seed round, earlier this year. And, we're now at the next stage of development for the company, where that brings us to, we're able to deliver, research scale kind of units, 1 or 2 at a time for these other companies' research programs or the government. And some of them are flying. So these are fully flight units, proto flight units, I guess. But now we're at the stage where the industry is ready to scale up. They need a lot more supply for these power electronics on a variety of different verticals and use cases. And so we are now about to prepare ourselves to get the capital we need and scale up massively. So it does become a scaling play. So we're there's 3 parts to it, basically. One part is making sure we can bring all of those variants to market as fast as possible. And the next part is to make sure that we can scale up manufacturing so that we can deliver on those customers when they're ready for us. And then the third part is just delivering on all the contracts we currently have in the backlog. So that's where we are today.
So you've been around for a while without raising capital. Were you just bootstrapping?
We've been very capital efficient. We've done 2 safe rounds prior to the seed round. So all told, prior to now, we raised in this, up through the seed round, we raised $4.7 million. altogether. And then we've earned like $8 million in government contracts. Some of those are still outstanding. We're delivering on, but so we've been able to leverage SBIRs and customer contracts to get heritage in space and make our investment dollars go as far as possible.
Oh, that's great. You haven't had to sell most of your company.
Not yet. I'm sure it's coming.
Well, it's interesting. It's probably, it's not it doesn't appear to be super capital, heavy until you get into scaling manufacturing. I guess that would be your.
Yes. Yeah, and really the need for significant capital now is speed. Actually, speed to market is the big thing here. We have an opportunity to be the dominant player in power electronics for the entire industry, and to do that, we will bring these various units, um, you know, to market or to a level of development so that our customers can say, "Oh yeah, I'd rather just buy theirs than, than do it myself." And I see they just raised a big round, so I know that they have the staying power to deliver this for me. Because you kind of need both of those elements for somebody to want to buy it. And we are already closing some of those contracts with larger players too for these future programs. So that's becoming a reality. Now it's just a matter of pulling the capital together for the next stage to make that happen. But it is less capital intensive than like building and launching a constellation of satellites or something, right?
Yeah, everything still takes capital, obviously. Size wise, how big are you guys?
Right now we're at 20 people, and we'll probably add at least another 10, over the next 6 months, like 10 to 20 more over the next 6 months, I would expect.
And are there other use cases outside of space for your power? Have you looked at like a dual use?
Certainly. I mean, one of the interesting ones is, we because we can do high voltage and we can also do pulsed power applications. Directed energy becomes a really interesting use case. We've heard of companies or countries deploying laser anti-drone systems, for example, on the ground. In space, there's a need for power beaming, to transmit power from satellite to satellite, and probably also for defensive kind of directed energy applications as well. But certainly on the ground, there's an opportunity to take that same technology and apply it to those use cases for drone defense. That's one of many. Like any kind of power dense system. So eVTOLs could be an application. There's stuff like that is certainly where it might make a lot of sense for us to get engaged. There's obviously a lot more companies that are in this market, but it's also a much higher demand, and there's just in the supply. So I think there's many areas that we miss to address the markets.
Awesome. And so when you're bringing your team together, let's fit a little bit to how you put your team. We've got some interesting backgrounds of, your COO with, NASA, DARPA, CTO with, industrial automation kind of system background. When you look to get out of here, how are you finding the right talent? Is talent a problem, or has it been, because Colorado does have a pretty good space ecosystem.
Yeah, I mean, so up until recently, we've always been able to find the right people that we need pretty relatively easily, but we're growing pretty organically at that point, right? So we had time to find those people. The way the team came together, I told you about the people from Space University. So originally, from that group, I have a German, a Brit, and myself, an American, and then Joe, another American who was added later as the last co-founder. Those guys all have different technical backgrounds in general, but interestingly, they're Joe and Walter in particular are also entrepreneurs in their prior lives too. So they have this really interesting mix of technical capabilities and business capabilities, and sales capabilities. So our CTO, for example, is also great at selling and going out and meeting customers and understanding their needs, which is not always the case for your engineers in the company. Lee, our COO, was our first executive hire. She came to us from the oil and gas industry, and so her background was in various size oil and gas companies including the big ones, running multi-million-dollar programs. In that industry, when the pandemic happened and oil went below zero, it's like, okay, I think it's time for a different career path. And she likes to say that she saw a lot of similarities between the space industry at that stage. She joined us, I think, 4 years ago now, and that stage and the shale revolution. So she was engaged in the shale revolution and helped to make that happen. And so she saw how the dynamics worked on that, and she kind of what says that there's some of the same sort of innovation and mixing things up that was happening in that context too. So we have that kind of industry backing, and now since we've started to scale the team up in the last couple of years, we've added people who have come from the space industry. So various companies like Maxar and Blue Origin and Blue Canyon and a number of other our supply chain person has background from Tesla and Lucid. So we're bringing these industry expertise in from different sources. In the very beginning, though, we just saw our learn space background as an advantage in many ways. I think it helped us see the opportunity with the power electronics that you know others weren't already capturing, because we didn't know we didn't know enough to know we should be afraid to use a new strategy or like to worry about the heritage question right as much. We just saw that this was working better, and we had a different approach. There wasn't this sort of the past experience was seeding about the future. So yeah, it's been an advantage, and I think now adding the space expertise is the killer additional piece of it to take us to the next level.
Yeah. Okay. So if you look in the next, 3 years, what are the big stuff? Sounds like really getting your product out there, like set a real, go to market motion.
Absolutely. Yeah, I mean, it's our ambition to be the dominant player in space power electronics across the world. I don't expect that we'll crack the SpaceX nut, and be their supplier because they're pretty vertically integrated in this world. But really, aside from the mega constellations that have enough scale to drive their costs way down, we could be the supplier for all the other power applications, especially as systems get bigger and more powerful, and being able to handle high power systems becomes the unlock for all these new capabilities on orbit. That's where our expertise really shines, where we deepen our advantage over what's out there today.
No, that's great. And who are you looking to other primes or other components? Are you trying, you've got contracts with like AFRL, and are you continuing that pace, or is it mostly just getting out to and talking with other manufacturers in space?
Yeah, so our customers they range from primes to small startups. We do have working relations with a few of the primes already. I think we've announced in other press releases that like on our current direct to phase 2 that we have with the Space Force, which is to build a dual mode PPU. We have Lockheed Martin and Safran Space, the U.S. version of Safran, as subcontractors on that program, so supplying different thrusters as examples to put together with this. So we've leveraged the SBIR program very well to be able to bring in those bigs as subs to us which they love because they have no other way of getting into these kind of deals. It allowed us to build a relationship with them. So there is a deepening of those opportunities, and there are big ones there. And then there's the whole host of new space companies that have a variety of different concepts, but they all need power processing. And some of them are moving really fast. And what we've noticed is that, like, most companies who need a power processing unit try to do it themselves, especially when it's a lower power level first. And it's only a couple hundred watts. That's cool. But then when they want to scale their systems up higher to meet these new opportunities, they start to run into all the problems that you get when you sort of run more power through these, conversion systems and the heat. And there's a variety of problems that crop up, right? And the gremlins that you start to see grow exponentially, the more powerful they get. So we're finding that companies are like, look, if you guys are making this thing, it's not our expertise. We're good at a sensor. We're good at a thruster or whatever it is that they're specialized in. And you're much happier to just buy it from us if we can deliver. So we're seeing a range from like across the industry, all kinds of different use cases.
That's great. Was it hard to raise capital? It's always hard to raise capital, but is your story, your thesis resonating with investors?
Yeah. So I mean, what yes, there's a couple things that are resonating now. So, we in the previous rounds, they were painfully lengthy. I mean, it definitely was more time than I expected was needed to get to those numbers. You read about the people who raise money in a week or whatever, like that's the stuff that makes the news, right? But I think it's much more common that it takes like a year to do a seed round, and it's a lot, right? Um, it's you kind of grind it out. What's resonating now, and we've just seen a market shift. I mean, we're also just closing out another safe, mostly to our insiders that are already investors in the company, and we were able to do that in like a month, and that's because they're looking at what's happening in the market. And not only are we seeing all these announcements of very big plans over the next 3 to 5 years from a variety of companies, everything from data centers to in-space power beaming and so on. But those companies are also coming to us. Like last year, for example, when we talked to companies at, say, the Space Symposium, one of the big conferences for this, they were saying, "Hey, we want to do a test with you, and we're working on a customer that we're going to need so many units next year if this closes." Well, those took longer to close than expected, and that also drove our seed round out longer, right? And then this year, when we went to Space Symposium, people were like, "Oh, hey, we just won that contract. Can you deliver, in 6 months this product?" So it's the materially changed, and the investors we talked to can tell. Not only are they hearing it in the news, but they can tell when we're talking about it that the nature of the relationship with the customer is just moved to the next level now. So it's become real, basically.
That's tough. That's a tough transition.
It's a tough transition, but it's a welcome one at this point because now we're through that crux, right?
Yeah, absolutely. Well, good. Well, I'm going to ask you some. We're going to start wrapping this up with some lightning round questions. So just give me your kind of top level hits, and we'll see where it goes from there. So, what's the biggest myth or misconception about selling to the DoD or DoW?
The biggest one I found was that I assumed they were going to be slow, really slow. And when we first got into the Space Force direct to phase 2, that first contract we won, and this was a few years ago, they were ready to sign a contract before we were. It happened so quickly that we didn't have all the things set up yet. We just thought we would have time, but so that was welcome to find out.
Good.
More efficient than I thought.
Hardest lesson you've learned while trying to build a space company?
I mean, I think it's really that the fundraising just takes way longer than you think it's going to, especially if it's your first time raising from, professional investors. You're an unproven quantity and you got to really prove it before they'll put their money in. But I was overly optimistic on how long that was going to take.
Okay. Number one piece of advice you'd give someone starting defense tech or space, tech company today?
I always tell people that if you're starting out, go to the conferences, talk to people, tell people about your idea, find out if there's a market for it. I don't think it's super valuable to keep it in stealth because you don't even know if it's needed in that case.
Yeah, and running companies is hard enough. If someone hears your idea, they're not going to necessarily put it.
Yeah, exactly. Like people are worried about people stealing your idea. It doesn't happen that often. I don't.
Yeah. Name a sacred cow in space technology that you think will be proven false.
Some of the sacred cows we try to fight is that it's just the time scales that people are used to with these programs. I think it can be much faster, but we're seeing that already from proven with companies like SpaceX. So I don't know if that's still out there. It is still out there. If you're talking to people from legacy companies, they need to see that it can be done faster.
And as you look across space, obviously you're in a place, but there are lots of other pieces besides power. What's the biggest opportunity you think right now?
The biggest next thing that's going to happen is it's related to being able to launch inexpensively, go to commercial space stations and bring things back. I think this idea of in-space manufacturing has seemed like it was, almost there, but kind of science fiction. It's going to be a massive opportunity. And, I think there's going to be a lot of really interesting medical advances and other materials and things that we didn't even think of to make there that, become real once the infrastructure is in place to do all this stuff.
All right. Well, Gary, this has been fun. Appreciate it. I think we're going to have to wrap it up. We definitely need to get together here since you're just down the street.
Sounds good.
But before we wrap up, if folks want to follow what you're doing, get in touch with you, how's best for them to do that?
Yeah, so I think you can follow what we're doing. We have a website, CisLunarIndustries.com. We post our press releases there. But I think the place that we're most active is on LinkedIn. That's kind of the social network for the space industry. You'll see our CTO post a lot on there, and me a little less so. But you can follow what our company's doing on LinkedIn pretty closely. And my information's like Googleable. I'm easy to find.
Well, fantastic, Gary. Wish you the best, and we will talk later. But thanks again for joining.
Sounds good. Thanks, Dave.